Hi, I'd like to welcome everyone to this session called Avoid Getting Fired. Start your automation journey today. Or put another way, Oracle Cloud Infrastructure Terraform Best Practices. My name is Tim Clegg. I work within Oracle, working with different teams around the design and adoption of secure, automated, scalable, and extensible cloud architectures. Now, today's session is going to be pretty fast and furious, a little bit for everyone here, where we're going to start talking about some of the basics around some of the foundational topics, really, that'll be applicable to anyone and everyone using Terraform largely, especially on OCI. And then we're going to delve into some more advanced coding techniques and tips and tricks, essentially. Finally, we'll wrap up with some different resources, which will hopefully accelerate your Terraform cloud adoption with OCI or Oracle Cloud Infrastructure. We're going to start off today talking about the state files. Now, state files with Terraform are an absolutely fundamental, critical component of any environment managed by Terraform. Terraform stores a lot of information in the state file, and some of that information is rather sensitive. And so guarding it closely and carefully, as well as making it accessible to your team as a whole, any of the administrators, is a really critical component. This is why placement of the state file is one of the first fundamental, crucial steps whenever we're setting up a new environment that's going to be managed using Terraform. Now, by default, Terraform will just set up a local state file. And that's great for doing sandbox type activities, testing, just kicking the tires, non-production type workloads. However, it doesn't scale well. It's not ideal for teams because it's difficult to manage who has the most recent copy of the state file, trying to coordinate who's applying changes and where those changes are getting stored. Are multiple people applying changes at the same time, getting our state file in an inconsistent state? Those are challenges whenever we're dealing with storing our state files locally. One option I'm going to talk about here and that I prefer and really highly recommend is storing them in OCI object storage. With versioning enabled on our bucket, we have an audit trail in terms of all the different changes throughout that state file. We have previous versions, and effectively backups, as well as an audit trail built in. Now, I don't have to worry about trying to coordinate between the team members because as I grant permissions to the applicable team members to that given bucket, they can automatically use it and have access to it in a highly scalable and available fashion. With all the benefits, you'd think it'd be kind of difficult, but it's actually really simple to provision. It's a two-step process. First step being create the bucket, and then the second step is just tell Terraform to use it. Super simple. Sounds really easy, and we're actually going to go through showing how that's done. Now, I do recommend using a distinct bucket for each environment that you're going to be managing or each state file. The reason is because we want to be able to give granular and distinct privileges or permissions to each bucket individually. They may or may not be the same teams and administrators leveraging each of those environments. Putting them in separate buckets gives us that opportunity. Now, here's an example. You can by all means go into the OCI console, service console, and provision a bucket. Here's how we might create it using Terraform. You can see here I'm going to give it the name of the bucket. Lots of other options available, of course, when we're creating it. And then secondly, when we actually tell Terraform to go ahead and use the bucket, you can see we reference the same bucket name, give it the key name, and of course other pieces of information, the region, endpoints, access keys, things like that are going to be unique for your environment. Now, this is available whether we have a brand new environment or we're migrating an existing state file. Documentation goes through how you might go ahead and leverage OCI object storage for storing your state file. Take a look at it. It's worth a read. Now, we're going to talk about naming, kind of a fundamental thing here. How do we name our files? Where do we put resources in their files? Oftentimes, we'll see main.tf or a really large monolithic file where all these resources are collected in it. And while that works, it's not necessarily ideal in my mind because it can be a little difficult to try to find a specific resource definition. What I like to do, just my kind of de facto standard, is I group up the resource definitions, the Terraform code, based on the type of resource that it is, and I'll put that within an appropriately named file name. So the compute instances, I'll put in computes.tf. Subnets go in subnets.tf, and so on and so on. This makes it really easy to where if I need to look for a route table, I go to routetables.tf. I can also have multiple tabs open in my text editor, do side-by-side comparisons, all that good stuff. Makes it to where I'm not having to hunt and peck so much within the environment looking for different resource definitions. Now, talking around naming of resources themselves, This is another area where oftentimes we see people putting the type of resource embedded into the actual resource name. So you'll see here, like in this example, we have subnet_web as the actual name of the subnet. OCI is really nice. Oracle Cloud Infrastructure is really nice in that I call it namespacing, where different types of resources are automatically separated. We see here in the Terraform example where the type of resource is an OCI core subnet. Likewise, in the console, I would access subnets by going to the subnets page. I'd access, if I'm using the API, I'm going to go to the subnet API endpoints. They're all different. And so I don't need to really embed the type of resource into the name, rather just call it what it is. Because I can see clearly here, it's a subnet named web. Likewise, when we're referencing them, much more concise and abbreviated, which is nice. Now, running Terraform, thankfully, especially within Oracle Cloud Infrastructure, you've got a lot of options here. These are just a few, of course, spattering. We have Terraform Cloud that you can use. It's just HashiConf or HashiConf Corp product. You can run it locally or within your data center. You can use Cloud Shell, and I highly recommend, actually, I'm not going to go into Cloud Shell here, but I do recommend that you attend a session of an esteemed colleague of mine, Luke Feldman. He's presenting a session tomorrow on OCI, Cloud Shell, and Terraform, the perfect marriage. So I recommend you take a look at it and attend that if at all possible, where he'll dive into greater detail around Cloud Shell. The two areas, particularly for team workflows, that I'm going to talk about is OCI Resource Manager, which is a managed Terraform service built in OCI, which is a great way to be able to deploy different types of stacks of Terraform stacks, as well as compute instances. Now, whenever we're leveraging a compute instance, something to keep in mind, particularly if you're deploying automated CI/CD or IAC type pipelines, is using instance principles. Instance principles is where I can assign privileges to a given compute instance and be able to not have to have additional credentials beyond placing the call from that compute instance. So long as the API call to the OCI API is originating from that compute instance, OCI knows what that is and has the appropriate permissions applied to it. So I don't have to deal with credentials. It's great for if you have like runner jobs or automated workers and the like that are running Terraform on behalf of a team. We're going to transition now into some more of the actual coding techniques and some of the different tips and tricks. Dynamic blocks are an area that thoroughly documented. So I'm not going to go into the basics per se, but what I did want to call out, and what I don't typically see, are more advanced use cases of dynamic blocks. I included one here. You can see the reference below if you want to see it in its entirety. We can do some really awesome things with dynamic blocks. In this example, we're iterating through a particular variable here, the security list variable. From that, we're outputting a dynamic data type, essentially, a dynamic structure here. And then we're also filtering for specific elements. So it's quite a few different techniques, and then finally applying those within the block itself down below. And so not only quite a few different things here that you can do that, again, don't always see highlighted or called out or too many examples, but worth taking a look at because it's very powerful what you can do with it. Now, there are situations where we have to dynamically provision multiple resources. And we could, by all means, have multiple resource calls. However, that's not too ideal. So what I'd like to do is show one use case where we can actually take multiple inputs, multiple variables from the user, and aggregate these into a single resource definition. In this case, we're going to be looking at network security group rules, where we have two different variables that are received from the user. We have var.nsgs, and we're looking at the ingress rules portion of that. And then we have standalone NSG rules as well. You'll notice that we're iterating through these, filtering them, and then we're using a common output data structure that's the same between both of these. And that's important because the next step is where we concatenate both of those local variables into a single local variable that contains both. The concat function allows us, so long as the data structures are the same, to be able to aggregate these into one local variable. In our resource definition, we then reference that local variable, which contains all of those inputs put into one. So it's a very nice, powerful way of being able to dynamically provision multiple resources from multiple inputs within a single resource definition in Terraform. Pretty powerful, and it's a nice technique. Now, when we're provisioning compute instances, we can by all means hard code the IDs or the OCIDs of the compute images that must be provided when we define the compute instance. A nice way of doing it, though, particularly if we're working with images in the public marketplace, is to use the data source. We then take a local variable and store the friendly name or the display name as the key. And then when we go to actually provision the compute resource, we'll take a variable from the user that has the friendly name and extract the ID from this data source. This eliminates the need to have any hard-coded dependencies, as well as working with, kind of these really long and sometimes difficult to manage, it can be difficult to manage random-looking OCIDs to where we can work with friendly names. Much more easier to work with, I think, from a user's perspective. Now, while we're talking about programmatically deriving things, availability domains is another area. Sure, we can hard code it, but let's use the data source. In this example, we're showing how we grab the different availability domains. And then you can see here, there's two different methods that I've shown. One is where we're hard coding based on a variable that's provided, and we're extracting the name from that data source. Or down below, if we simply wanted to make it more dynamic based off of the count, how it would be extracting that based on the count index. And so that's a nice way of doing it. However, for bonus points, what if we wanted to dynamically stripe resources across any and all availability domains in the given region that we're working in? This can be done. Here's how. Take a look. So we set up a local variable called number of ADs, and then we simply modulo based on the count, modulo against the number of ADs. This will, whether we're in a single AD region or we have a region with 3 ADs, it'll automatically stripe the resources across each of those availability domains, which can be pretty nice. Nice technique. Now, defaults. When we're talking about user interfaces and the defaults for a Terraform code, this is the technique that I like to use. I like to put all of my defaults as a map at the top as a local variable. And then below, whenever we're attributing or whenever we're setting those different variables, going ahead and setting the variable, looking for user-provided input. If I don't see it, I'll fall back to the default. All of my defaults are up at the top of the file in one location, which is really nice. Another nice technique. Now, when we're iterating different elements, we can use count or we can use for each. Count by itself is great if I'm just going to throw some resources up there and I don't need to get at them later. I don't need to reference them individually later. For each is a very nice technique, though, where if I need to be able to reference an element at a later time, I can go ahead and do that based on a key. Now, the kicker is that the keys cannot be overlapping. They need to be unique to the environment. And so that can be a little bit of a challenge. The main reason why count is not so great for referencing later is because between different executions of Terraform, the actual indexes of those different elements, the ordering within that list can change between runs, which isn't too ideal, especially when we're accessing it by index. Now, here's an example where we've got a variable defined in our code. You can see here, you can see the resource definition, how it's used. We're using for each in this example. And then we have the user provided data, where we have a key here of inst simple. And then the reference of that is very simple. It's very clean and straightforward. The kicker here is, again, if I have multiple instances, I need to have inst simple 1, inst simple 2, inst simple 3, and so on. You really need to make sure that they're unique and specific keys used. Count is handy as it serves a dual purpose as well, though. We can actually use it to disable creation of a resource. So if I set a particular logic here, count for a resource, have a logic check. If that passes, I say, yep, go ahead and create it, create a single instance of that resource. If I set it to 0, it will actually not create the resource at all, which is kind of a handy technique. Now, here's some different resources which I hope will be of help. We've compiled a large number of Terraform solutions in Oracle Quick Start on GitHub. Highly recommend you take a look at that. We also have an architecture center, which has many customer-inspired reference architectures, as well as many of those accompanying with Terraform solutions built for you. And then, of course, different modules, which hopefully will accelerate your journey on Oracle Cloud Infrastructure. I'd like to thank you for your time. It's been great. It's been fast and furious, but I hope you've gotten something out of this, and hopefully you have a wonderful rest of your day. Thank you again for your time. Have a great day. Thank you.